Hello everybody! In this video we're talking about adding rational expressions without common denominators. And you'll see that this process is very similar to the way that we would add fractions without common denominators. First thing we need to do is find a least common denominator. Looking at these two denominators, you can see they are not common, so we need to find that LCD. And the way that we do this is we are going to factor both denominators. So if we factor this, we set up our two binomials. Of course, x goes in the front to give us the x squared. And then what two numbers multiplied together give us positive 4, but when we add them give us negative 4. Well, that's just going to be negative 2 and negative 2. So now that is completely factored. And we look at this one on the right, and to factor this, again, set up our two binomials. X is going to go in the front, as x times x is x squared. And we need to find two numbers that multiply together to give us negative 12. But when we add them, give us positive 4. And thinking about this a little bit, that is going to be positive 6 and negative 2. So now the right one is factored as well. From here, we can find our least common denominator by multiplying those unique factors together. You can see this can be simplified to x minus 2 squared. And so when we have the same factor between the two denominators, remember, we're only going to use the one with the larger exponent. So you can see this is x minus 2 squared, so we are going to use that one, x minus 2 squared. So we've taken care of those. And then our final unique factor is this x plus 6. So here is our least common denominator. From here, we're going to rewrite both of our expressions using the least common denominator. So they're both going to be x minus 2 squared times x plus 6. And then rewrite this. This is also going to be x minus 2 squared times x plus 6. So now we need to change our numerators to reflect the same change we made in the denominators. So we have to ask ourselves, what did we multiply each denominator by in order to get the least common denominator? And we have to multiply the numerator by the same exact factor. So looking at this first one, we have x minus 2 times x minus 2. What did we add to it to give us the least common denominator? Well, we added to it, well, we didn't add to it, but we multiplied x plus 6 to give us the least common denominator. So we need to multiply the numerator by x plus 6 as well. Looking at this second expression, here is our original denominator, x plus 6 times x minus 2. And what did we multiply the denominator by to give us the least common denominator? We multiplied by another x minus 2. That's how we got the x minus 2 squared. So our numerator needs to be multiplied by x minus 2 as well. From here, we can just add our numerators together, and our denominator is going to stay the same as the least common denominator. So we can distribute these in here. So it gives us x squared plus 6x. Distribute this in here. Gives us a positive 8x minus 16. And that's going to be over our least common denominator, which is x minus 2 squared times x plus 6. From here, we can combine like terms. There are no other x squared terms, so that's going to stay the same. We combine 6x and 8x to give us 14x. And then there are no constants to combine with, so that is minus 16. And then we are all over x minus 2 squared times x plus 6. From here, you always ask yourself if you can simplify this. We can actually not simplify this, so this is our final solution to when we add rational expressions without common denominators.